Hi students, this is a breakdown of the model of hydrogen. Hydrogen is an incredibly important element. It is it is the simplest element in the universe. It is also the most abundant element in the universe. It is estimated that something like 75% of the universe is composed of hydrogen in various combinations. It is an important part of life. Something like, if you were to break down a human by mass, something like 10% of your body, component-wise, is made up of hydrogen. So in order to understand life, we need to understand its component parts, meaning that we need to understand at the atomic level, predominantly carbon, hydrogen, and oxygen, along with calcium, phosphorus, sodium, and chlorine. Today we're going to be looking at hydrogen. Hydrogen is the simplest element in the universe. It is made predominantly of two particles, one positively charged proton and one negatively charged electron. There are variations, though, that we will also discuss. So hydrogen is the simplest element in the universe, and hydrogen is composed of one positively charged proton in the nucleus and one negatively charged electron in its first shell here. Let's use a different color to try and differentiate. This is as simple as an element can get. The proton's positively charged force and the electron's negatively charged force are attracted to each other. They keep it in balance. You can't have a particle with you can't have an atom with fewer particles. The hydrogen bomb, as you may have heard of, is the result of a giant explosion. When we have figured out how to successfully separate the charge, the electromagnetic force that keeps the electron and the proton attracted to each other. If you can do that, if you can input enough energy to force these things apart, it will release a tremendous amount of energy that results in a gigantic explosion. This is as simple as you can get. There is nothing simpler in the universe because you cannot have half a proton or half an electron. One proton, one electron. That's as simple as it gets. This is not the only configuration of hydrogen that is possible. It is also possible to have what we call isotopes. Isotopes are variations. So just like you can have a black hoodie, that might be the most common hoodie. Someone else might wear a red hoodie, which is less common, but it's the same concept. So there are variations of hydrogen that are heavier, and they have one proton and one non-charged neutron within the nucleus. They still have one electron So we can see when we're comparing this nucleus, the nucleus is larger in deuterium because it has an extra particle than in regular hydrogen. So this is the most common form of hydrogen. Approximately 85% of hydrogen is found in this form with an atomic mass of 1. AMU standing for atomic mass units. This variation is heavier. It has an atomic mass of 2. So it is heavier. The neutron has a mass just like the proton. Electrons have a mass, but they're incredibly tiny. An electron is something like 1/2000th of a proton. So it's not a tremendous component of the mass of the element. And then the other isotope that occurs in nature is tritium. Sorry, deuterium is approximately 12% or so of all of the hydrogen that exists. It is a heavier form, but it is much rarer. And tritium is even rarer. Something like 2 to 3% of all of the hydrogen is tritium. And tritium, so tri meaning 3, would consist of one positively charged proton, but 2 neutrally charged neutrons. And still, in this case, one electron. So these are all hydrogen, and we say that they're all hydrogen because of the fact that it has one proton. Really, the behavior of the element is, or I should say, how we classify the element is based upon the protons, because the protons are the most stable part of the atom. Neutrons, there are variations. As we can see, there's 3 naturally occurring variations. And electrons come and go depending upon how the element bonds to another atom. So we categorize the atom by its number of protons. So there's no such thing as a hydrogen with 2 protons. We would just call that helium, because helium is the atom that has 2 protons. So there you have it. Hydrogen exists in nature in 3 different forms. The vast majority of hydrogen is found in the standard form of 1 proton and 1 electron. It's something like 99.9% of all of the hydrogen atoms that exist are in that form. I think I said 85%. I double-checked that, and that is incorrect. 99.9% of hydrogen exists in the form of standard hydrogen, and then 0.012% exists in the deuterium form, and then 0.003% exists in this tritium form. Now, because these isotopes have a different atomic mass, they have different behavior. They're heavier, so that affects how they interact with other elements. The key takeaway here is hydrogen is the simplest and most abundant element in the universe, and because it has 1 electron, it will bind in various different ways as it seeks out a second electron. In that shell, up to 2 electrons can occupy that shell, and so hydrogen will seek out to fill that shell with 1 final electron in various configurations. So it will bind with another hydrogen to produce hydrogen gas. It will bind with oxygen and another hydrogen to produce water. 4 atoms of hydrogen will bind with carbon to produce methane. There are incredibly wondrous number of combinations that hydrogen can bind in order to seek out to fill its shell with an additional electron. That is the most stable configuration for hydrogen. If you think about pure hydrogen, it is very reactive. It will easily burst into flame because as it reacts to the energy input, whereas something that has 2 electrons in its shell, like helium, does not react to the environment as easily. So hydrogen is seeking out a partner to help it become more stable, to fill its shell with a second electron.